Hey guys, welcome back to my channel. So today's video is going to be about exploring the Llama 3.2 Vision LLM model and utilizing it into a Streamlit app to read content from an image that you input into the model. So if you want to know how to integrate this into a Streamlit app, just keep on watching. All right, so first things first, we're going to need a file uploader to import an image in cache in the app. So that's what I'm doing here. I'm using the SD file uploader component and specifying the allowed types to be either PNG or JPEG. Now we got to do a bit of transformation on the imported image to convert it into a base 64 encoding so that the LLM model can actually read the image. So to do so, I'm using these libraries here uh, and doing these transformations here. And finally, I'm displaying the image into a Streamlit app like so using the SD image component. So yeah. So if we try it out, let me import an image into the app. So with the file uploader, we see the this image, which is a target receipt that we're gonna try to analyze with the app. All right, so the next three sections are three distinct features that I've added using the LLM model. They're all following the exact same logic. So we have a describe feature, an extract feature, and then finally a summarize feature. So if we start with the describe feature, here I'm using the Ollama library to extract the Llama Vision model. So it is very simple to use. You have the chat method that allows you to select your desired model. So here, of course, we're going to use the Llama 3.2 Vision model. Then you input a prompt to send to the model. So here for the describe feature, I'm writing this prompt that reads, describe the content of the image in detail, including objects, scenes, and any visible context. And also specifying to provide a concise and well-organized description. So this is the content part. We can also import the image from which we want to extract some content in the images key. As you can see here, we're using the base 64 version of the image so that the model can read it properly. So then when we get a response from the model, we display it in the app with a markdown component with some styling that I've set up here. And then it looks like this. So you have an expander with the image description title and for which we have the output of the model. So like I said earlier, the other two features follow the exact same logic. So the extract features prompt reads extract all text from this image accurately, preserving line breaks and formatting where possible. So I'll put the text as plain text without any explanation or comments. And it looks like this. So you have the exact same component, and the summarize feature reads extract the text from the image and summarize its main points, provide a brief summary in 3 to 4 bullet points. And you have the exact same thing here. So after all this, I merged these features together and got the following app. All right, so we're gonna test out 5 different types of images today with this app. So we have receipts, logos, news article, and one image of a graph that we're going to try to extract content from. So let's start with an easy one, which is an image of the Google logo. So let's import it, and it's processing the data. So we have the 3 features that we have integrated into the app. So let's see how it performed. So the image description seems to be very detailed, even mentioning each letter's colors. But that clearly explains what the image is. Now, as for the text extraction, although it did provide what is actually written in the image, I feel like it is way too overkill with all this description here. I may have to refine the prompt so that it doesn't give that much details, of course. And as for the text summarization, again, we only have the Google logo, which is pretty hard to summarize, but the model seems to still provide a very detailed response in some bullet points. Okay, so next, let's try to read content from some random target receipt that I found on Google. Let's wait for it to process. And let's see how the model performs. So as for the image description, so the model correctly recognizes the image as a target receipt, which is cool, and provides a lot of details on the format of the receipt, which is pretty impressive. It even provides the total amount of the purchase that sums up to 65.77, which is actually, yeah, the correct amount. As for the text extraction, it seems to have correctly read every single item from the list with its price, as I can see here. Yeah. And finally, as for the text summarization, we get essentially the same information but aggregated or summarized into bullet points, which is pretty neat. So next one we're going to try is a Best Buy invoice, which has a lot more components than the target receipt. Let's see how it goes. So again, very impressed on how the model is able to read all of this. Again, very detailed and valid information. We have a lot of numbers, dates that correctly matches with the image and content. So about the text extraction, again, very impressed on how it matches every single information. And as for the text summarization, again, we have essentially the same information but in bullet points. Next one, I wanted to try to screenshot a news article to see if the model would be able to read it. So it seems that the model has been able to do so. And the thing that I really like is the fact that it recognizes that there is a photo within the article itself, which the model mentions here. As for the text extraction, it is pretty much the exact same content that we have in the article. And as for the text summarization, again, a very detailed summary of the article with bullet points. Last one we're going to try today is an image of a graph. I wanted to see how the model perform with this kind of image. So let's see the image description. So it seems to have very accurately identified that it is a plot. It even have a detailed description of the graph with the x-axis, the title, and even the range of dates, and provided even some insights on peaks and drops or lowest points within the time series that is provided into the image, which is pretty impressive. As for the text extraction, I feel like it's a bit limited, but it's still interesting to see that it has extracted some data points from the time series. So we have, for instance, the 1970 year that have a $0.95, which feels like it matches, yeah, approximately. And as for the text summarization, we essentially get the exact same information. Actually, I feel like it's the exact, yeah, I feel like it's the exact same information, which is a bit of a bummer. Maybe I have to, like I said earlier, refine the prompt to have a better response. So yeah, that's basically what you can do with this kind of model, the Llama 3.2 Vision model. There are other models that you can use with the Ollama library, but this is one example of it. So if you like this kind of video, please share, like, and subscribe, and I'll see you in my next one. Bye, guys.